All right, I guess for people here and people online. All right, so my name's Michael Sakamoto. I am from UL, and we've joined OCP around April this year, toward the end of April, I believe, and then we've immediately got involved in this immersion cooling project. I'm really happy to be part of this community right now, and hopefully over the period of years to come, we can continue to contribute from a compliance standpoint. So today, kind of want to walk through very quickly at a very high level, because we only have 15 or 20 minutes here, to cover some of the things that should be under consideration as you look at safety compliance for immersion cooling technology. So with that, that's who my name is, just in case you couldn't catch it real well. So in the certification categories, we've looked at 3 key areas that should be looked at from a compliance standpoint. The first is the hardware, which is the tank, is that, if lack of a better word, the hardware or the tank. The second is the insulating liquids. Now, I use this terminology, and I know we talked about terminology, and there needs to be probably alignment within the industry of proper terminology, but insulating liquids is what's really being used in the IT industry, the computer industry, in terms of standard development. So that's why I'm using this as a reference point, because as we go through the slides, you'll notice that some of the reference I'm trying to provide OCP community is what we know and the knowledge we get from the information technology standards that's used today in the industry, which are globally harmonized, which is the IEC-62368-1. So the third piece is going to be the installed information technology equipment, and simply the servers that go in there, and what needs to be looked at when a server goes into a new environment where traditionally they've been air-cooled in a rack. So we'll go through these 3 pieces a little bit, step by step. You may have questions, and I told people, typically in compliance, somebody asks a question, the answer is going to be 20 minutes long. So maybe the better idea is to hold your questions, and then after the presentation, if you got a question, I'll be around for the rest of the day, so you can ask me questions and exchange contact information and everything else. All right. Oops, sorry. So let's talk about the hardware. So this is the tank in itself. And right now, as it stands today, there are 2 defined approaches that we can look at in terms of the tank, physical tank. The first approach, and this may not be the common approach, but the first approach is a tank and the servers preloaded, which means it is pre-configured as a set configuration. If that is what you have, then we can certify that today to the IEC 62368-1. So that exists today, and in this new standard, the 3rd edition, which I'll cover, they have brought in some additional requirements to make sure that the insulating liquids used in this technology has some requirements, and I'll cover that in a future slide. So that's the first approach. The second approach is something that we just came up with and announced early this week, which is the UL 2416. And this is basically an empty cabinet. We will basically certify an empty cabinet. And what we did is we took a standard that exists today in the industry. It's an ANSI standard, so it is recognized by a lot of the authorities having jurisdictions, because that's what they would look for if it's an ANSI standard. And it's traditionally, 2416 has been an air-cooled rack, empty rack, or configurable rack. What we have done is we created a separate category using the same structure and the concerns, and then apply that to the immersion cooling system. So that's what we've done. We can start with those today now, and so those are the 2 sort of approaches that we have for the immersion hardware side. Okay. So let's talk a little bit quickly about what 2416 is. 2416 is an ANSI standard, and currently it's for a category that covers air-cooled racks, cabinets, and power distribution fans that are not complete systems. So, maybe the fans aren't there, maybe even the power distribution systems are there, but typically it's a cabinet that gets installed, and the user just populates what's in that rack. And that's what we see currently what we see in immersion cooling, is that a lot of the tanks are getting sold, and the customer starts to populate the servers that go in there. So we think this is probably a more lucrative solution for the industry. So we can continue to do this, but in a different application, the immersion cooling application. Now, in the 2416, it references a lot, it pulls references a lot from the IEC or the UL 62368-1. And you'll see this 62368-1 quite a bit in my presentation. And as you look at compliance, you're going to see that a lot too. And 62368-1 is an IEC standard. It is a globally harmonized standard, which means it's recognized in Europe, Asia markets, North America markets, pretty much globally. And it addresses the safety, it's a safety standard that covers information technology, communication, and including the traditional audio-video equipment. So this is why it's important that we also look at immersion cooling and make sure that there is some sort of a collaboration between 62368 and what we're doing here in the immersion cooling systems. So what is just a very high level, because when you talk about testing in a standard, it could get really deep, so I just do it in one slide. What are we doing in testing or something like this in a 2416? Well, we'll test the cabinet. We'll need to also test the insulating liquid that comes with the cabinet and a load. Now, everybody's questioning, well, what do you mean maximum load? Well, we don't really care what servers you're putting in there. We just want to know that there is a specification of a load, a maximum load in a cabinet, and we want to make sure that if you put that load in there, there are no safety concerns in terms of electrical shock or fire or thermal or anything else. So it doesn't matter how it could be anybody's stuff or it could just be a load, and we can still test it to make sure that it is considered to be safe. So it gives you a little bit of flexibility as you work with your customers in terms of, hey, I have a cabinet, the customer's going to populate it, but how do we test it? And the testing is not specified to a server, it's basically based on a load. So that would be the key thing that I would like to point out here. Now, with 2416, there are manufacturer's responsibility. And this is going to be basically that you have some ability to instruct the customers on and recommend what servers that have been either qualified or tested so that they don't just randomly start putting things in that are not properly qualified to be in that tank. And I think a lot of you already do that, but that is going to be part of a 2416 requirement. And a lot of it, it's just an audit to say, do you have the proper instructions? Do you have the proper guidance to an end user to say, hey, you should be using these. In fact, we have a list of servers that we used and tested with and validated with our tank. These are the servers that we recommend. So those sort of instructions and guidance should be part of your overall compliance, a path to compliance under a 2416. Okay, now I mentioned the 62368 earlier. The third edition of this globally harmonized standard for IT equipment was issued back in, well, it's a 2018 edition, but it was issued in 2019. And as you can see, and I don't want to go through each one of these in detail because, again, it'll take probably 2 hours to go through this. But you can see that there are a lot of, not specifications, but there are requirements put into the standard that was never there before. It wasn't in the second edition. It all of a sudden popped up in the third edition. This means that this technical committee that is responsible for driving the requirements is understand that this technology is coming. And they have to address it because the servers that they certify are going into this hardware. So if you can see, a lot of the stuff that they have already started to address is regarding the insulating liquids. They're concerned about that because you're taking air-cooled hardware and you're doing something and you're putting it into a tank with dielectric fluid. So they're starting, but it's just a very high level. If you look at any of these clauses in the third edition, it doesn't give a lot of detail. It's sort of vague, it's very high level. So there's some opportunity and I'll talk a little bit further about call to action, but there's a lot of opportunity for OCP to interact with the technical committees of TC108 of 62368 and be able to provide guidance and proposals so that this is a very harmonious relationship between certification of safety standards and the requirements that OCP is putting together. But as you can see, there's a lot going on here already. And they're already starting to set up their standard to start to address some of the safety attributes of this technology. All right. I know Rolf just looked at his clock. Okay, good. Thank you. The insulating liquid. So this is the second part, right? The insulating liquid. The insulating liquid is considered a critical component So what that means is that that is a component that they're going to have interest in making sure that is going to be operate safely in the hardware. The third edition, as I mentioned earlier, as I showed earlier, does have the requirements that are starting to address the insulating liquids and the safety attributes of that. And then what I did is I sort of listed 3 parameters that they did start to specify, right? So one is the auto ignition temperature, not less than 300 C, flash point higher than 135 C. And this third one, I'm still sort of debating if this is really good or not. You know, maybe it's a little vague or it doesn't make any sense to a lot of people I've talked to. 60-day aging for dielectric breakdown. So again, I'm not saying that you have to agree with any of these numbers right now. What I'm trying to make sure that you understand is they're starting to make moves in attempts to understand and make sure they feel like they need to address the safety attributes of this technology. And I can tell you honestly that this technology and just also being involved with OCP, I've seen this technology just hockey puck, right? Just taking off. And the standards, the groups that are managing the standards are sort of looking at it like, okay, we got to do something fairly quick. So there is a need for this. So as I get into the subsequent slides, I'll sort of give you a little bit more understanding on how that works. Now, 2 approaches for the liquids that we can do today. First one, we can do it as an unlisted component. That means whatever liquid that you want to certify the hardware system, we can certify that liquid in that system. So it's pretty locked and fixed. Like if you have multiple or you don't know which liquid is going, maybe this isn't the way you can do it. But if you have 2 or 3 liquids, you can test it with all 3 of them and put that into your certification file and it says our system works with all 3 fluids or 2 fluids, right? So there's a little bit of flexibility built into that. So that's one way to do it. The other one would be clearly just a standalone certification of the fluid itself. And I know we are doing quite a bit of work right now in our research lab to come up with parameters and ways to test to have a fully certifiable standard for insulating liquids. So this is something I think we have a team, my colleague that's involved in the project also, that's involved in a dialogue with the OCP project group right here. So this will keep going on, but it's currently under development. But I think if you look at a lot of the bigger companies that are doing insulating liquids only, this is probably a proposed path. Okay, so the installed equipment. This is the servers that are going into the hardware. So there's a couple ways we can do this. And we've had a lot of questions on this because we have relationships with a lot of server manufacturers and they ask us, well, what do we do? So a couple things we can do. Now, if you have a server that is strictly designed to go into immersion cooling, that's fine. We can take 62368 again and certify that product in the new environment. And because that server is clearly designed and built and made for and will be tested to that new environment. If you have an existing server that is certified, it's been certified for air-cooled system, and all of a sudden you want to pull this out and say, all right, I want to be able to use this in my immersion tank, and but I got to take off the fans, I got to take off the heat sinks, I got to take all this stuff off, I got to modify it. Then what we can do is we can keep that same hardware, what they call a file, it's a certification file, but we add an alternate construction. So you have an air-cooled construction, immersion-cooled construction, and we test it in both environments, and you can put both of them in the file and have them both certified. So these are the 2 current approaches that exist for the hardware. And we had some discussions with some hardware manufacturers on this already. So, and now, what I'm presenting here mostly here is what we have today. As the discussion progresses within the community and everything, there may be other things that may pop up. We may go, maybe this is another way to do it. So it's sort of open right now, but all I wanted to do today in the 20 minutes I have is to actually sort of present some of the things that we can do today and some of the considerations that are given today, but give you a little peek about what's going on in the future and how we can influence what that future looks like through the OCP community. Okay, a couple things from a standard development and regulatory. The things that I kind of want to mention here is that the standard development for like 62368, it is a global network of technical committees. So there's a US committee, there's an Italian committee, there's a UK committee, there's all these different committees that individual manufacturers will join and become a participant. And that all rolls up into the IEC, the mothership IEC TC-108 technical committee. And those are where the final decisions are sort of made. So in many cases, a lot of the people that I work with directly in North America, they belong to what they call the US TAG, TC-108 TAG team. And what they do is they present different things that are going on. So that is the thing that is going on. And when we get to the call to action, I'll kind of bring about what we would propose doing here. But the other thing is make sure that you understand, and you guys, a lot of you know this because you're in the data center environment, that code authorities, HJs, right, authorities having jurisdiction, they're very critical. And to permitting and allowing you to commission things and new equipment that shows up into the data center, and they will be looking for like a UL mark. And sometimes if they don't see that, they're going to say, no, you can't turn that on. Right? They want to see, they won't issue a permit. So just keep that in mind as you go through this, that this compliance isn't something that you just think, do I need to do it or not? In a data center environment, it's probably critical that you do, because the authorities having jurisdiction will come in, they will start inspecting, and if they don't see something that doesn't have the right credentials on a product or a system, they're going to tell you to turn it off and get the certification done and come back to me. So just kind of keep that sort of thought in mind. Okay, call to action. I think this was my last. Oh, there's two more. So we're going to continue to collaborate, obviously, with the OCP. And right now we're in this Advanced Cooling Solutions, the Immersion cooling group. We're going to continue to do this. I know we sort of started, and I'm doing a lot of soaking in right now because we're learning a lot from the community groups. And I know that there's collaboration going on, and it looks like maybe this month we'll have that requirements document done. So the whole idea is to get the requirements document done, take a review of that, and let's create a roadmap where we can actually present and propose to the technical committees that drive the IEC standards, the 62368 standards, and present that to them so that they understand what is really necessary from a safety critical standpoint. And this is really important because right now, the technical committees that drive the standards, they're looking for subject matter experts to be involved. Okay, thank you. So there, and in fact, what we did is that we actually did a little bit of pre-work, I should say. And we talked to the vice chair of the TC-108, the big mothership decision-making body, and they said that, yeah, we need subject matter experts on this to give us advice on what requirements are pertinent to safety in this technology, because it's coming in quick. And we really don't want to be sort of blindsided and have issues in the field. So we already made a couple of contacts, and they're saying, yeah, we need their help. So John, Rolf, and I have been talking a little bit, and we said maybe the best way, instead of individual manufacturers, you can still do it. You may have your own companies, may be represented in one of these local groups of TAG groups or technical committee groups. But I think there will be a much more stronger weight provided if OCP, as a consolidated group, goes and proposes to the 62368 standard and say, hey, listen, these are the safety critical values that should be involved in a hardware standard. So that's sort of my key takeaway for this, is that's the next step we want to get to. So right now I'm kind of sitting through watching the requirements document get finalized, and once that gets finalized, then that's kind of when we sit down, and then we'll set up OCP as what we call Liaison A, which allows an entity to go directly to TC-108 and propose solutions and requirements for safety critical aspects and requirements for the standard. So I think that's all I had. This probably says the same thing, so I don't need to sort of it's probably quicker to saying it, so. Yep.
Switch the mic on after mic.
Oh. So do we have time here, or are we good?
One quick one, Mike.
Yeah.
UL 2416, the modified version?
Yes.
Is that in John? Now people can buy it?
Not yet, but we will get there very quick, so, yeah.
Okay.
Oh, yeah.
Just for the record, repeat the question, please.
Yeah, the question was UL 2416 that he referenced, whether it was in print yet, and
I'll let you answer it again now that you know the question.
Yeah, so, I'm mic'd up. Yeah, so it's not ready for publication where you can just go ahead and get it, but go ahead and contact me if something is something you want to do right away. We do have a program draft that I can probably share with you in terms of what's required and what's necessary, so we can get started. That's fine. I have no problem in doing that, so, yep.
Could you briefly explain the scientific reason why the current flashpoint limit is 135 C and above?
Okay, you know what? I probably wouldn't be, if I would attempt to answer it, it may be wrong, and then it could take 30 minutes, so probably not a good, but, give me your contact information, I'm done, and I can try to, get the rationale behind why IEC TC108 decided that should be the flashpoint.
Okay,
Keep in mind, a lot of these safety standards, they're looking at very minimal values, right? So keep that in mind as you go. But if that doesn't seem to fit in terms of what your rationale is, then this is something you should bring to OCP, and that could be a reason to propose to the IEC committee why what they're thinking is probably not adequate.
Thank you very much, Michael. And I think we're ready for the next session. Done? Thank you, Michael.